some introductions first. Nick, you want to kick it off?
Sure, Marty. Hi, my name's Nick Mundell. I'm the director of core modeling at Core Studio. So I'm the Core Studio representative on this call today.
And I'm Marty Rizmaneth. I'm the Chief Technology Officer and a co-founder at Skema. And with me is Nikita. Nikita?
Hello guys. I am head of product development in Skema, architects in the past, so kind of a passion about technology, and happy to be here today.
All right. With that, I'm going to do a brief introduction to what we're doing in this virtual workshop today. And then Nikita will run most of what we're doing here since he's our R&D lead. Let's see. Apparently I need to send a request to get sharing.
In a way, I'll try and get back to you.
All right. And Nikita will also need it too. So. All right. All right. With that. We'll start here. So this is what we're calling the Extending Design Intelligence Workshop. It's our first launching of the development features of Skema, and we're going to show you examples of how to use it in Grasshopper. Now, it is the first time we've ever done this, so this is pretty much what you can consider an alpha API launch. So we're going to be walking you through the guts of it, and then we'll be talking about where it might go from here. I guess just from those that are in the room, how many of you had had any plays or tries with Skema to date? Like just with a show of hands. So, okay. So then what I'll do is I'm going to do a brief overview of what Skema is and what it does. And then we're going to talk about how that works programmatically with Grasshopper and the content of the workshop. And so let me introduce that. So what we're going to be doing today is we're going to be querying an analytic model out of Skema that we maintain for buildings that are being designed using our conceptual and schematic design environment. Part of developing Skema was working with architects over the last 2.5 years. Those architects obviously use tools in their office already, and we ended up implementing a concept that we call the Swiss Army knife because we didn't want to recreate every feature in SketchUp and Rhino. So we've turned Skema into an extension that allows it to run alongside and synchronize data with other systems. And so we're going to put together a number of things today: Skema, the API with Skema, with parametric facade and Grasshopper, and then using Rhino inside to turn that into Revit geometry alongside the Revit geometry that's produced by Skema natively for the rest of the building, so that you can combine all these things into one workflow without needing to do file wrangling or file exchanges. So let's talk about first what Skema is for those of you who aren't really familiar with it. As I said, as we were working with architects over the last couple of years, we didn't want to have to recreate every feature in every conceptual and schematic design application. So what we did was we created an extension architecture first with SketchUp as part of a Trimble accelerator and launched that. And then we've been systematically applying that to other tools like Rhino. And then while we've always had this ability to generate high fidelity Revit models, we've use that same extension architecture to make it bidirectional and give Revit the same two-way interoperability that we have with Skema and Rhino. The whole purpose of Skema is to reuse assemblies in Revit. So we start with input from previous Revit projects, and the way that we handle that input is that we parse it, create a graph, create an analytic model, and then that allows us to treat that assembly flexibly using a process that we call morphing. Although we'll refer to that assembly as a unit because oftentimes when you're laying out residential or hospitality applications, that's how you'll call them. And we have a lot of users doing that sort of thing. They're really a flexible tool that can be applied to just anything that you can group in Revit and turn into a chunk that is useful to you in laying out something. So we've had people do that with compute units and data centers or other things in retail. So that idea of the unit is really something that is very general, although it is associated with apartments and hotel rooms. It doesn't have to be. And so once we go through that basic understanding, we're going to show you how to do that programmatically so that you can access the geometry services in Schema so you can locate things relative to the building that it creates and then use that in Grasshopper applications to do a number of interesting use cases. This actually came up for us in working with customers where we would generate the outside of the building based on the input that we got from Revit, but then the architects would want to change it and they'd want to do something custom and they'd want to use computational design to do something custom. So the whole part about this is that we're not doing this with files. We're doing this with web services and JSON APIs. So that's why we're going to be walking you through how to use the JSON API into Schema in order to be able to do this data transfer back and forth between these different applications. And we'll be using some custom facade as real world cases just to give you a good example of how to do that. Now, in the future, whether this turns into a Grasshopper plugin on its own or some other implementation, we're interested in your feedback and I want to find out how it would be most useful to you. Like I said, this is sort of like the alpha launch of this API. All right, so I talked about units before. The reason units are so important is that they determine the behavior in Schema. So we have something called a design catalog, and every customer that you can think of as a company, but it could also be a team. So when we're doing the hackathon, for instance, that team will have a tenant and that team, all the people on that team will be working inside that tenant. The tenant itself has a catalog management capability, so you can have multiple different catalogs. It's really up to Schema users how they use this. It could be different catalogs for studios. So if you're in a professional architecture firm or a design build firm and you specialize in healthcare and education and residential, you can have catalogs for each of those studios. And in fact, you can have multiple catalogs for each of those studios. The catalogs are built from Revit data from previous projects. And we have mechanisms for cleaning up that data because as we've worked with architects, we find that people's Revit files are kind of like a cluttered garage full of things, not always well structured. And so because we don't want a garbage in, garbage out situation, we have a data quality assurance mechanism, and that's really the part of Schema that is the AI part. It builds a graph and then determines how to tag things like walls and spaces and things that form closed topologies so that we can treat those things as a chunk of a building that can be used and in fact then can be changed in size and shape in a rational way so that when you make a new version of something out of it, it understands how to adapt to that new size and shape. So when you bring things in from Revit, and this is again typical in situations like apartments and hotels, but can be anything, classrooms, MRI labs, patient units, whatever. We're going to parse that and create our own representation of the analytic graph of the connected elements and then all of the things in relation to that analytic graph. And then when you use Schema, you're going to see it as simplified shapes that look like this, where we show you the orientation of the unit because you can see where the walls and doors are. But we're not going to show you every piece of detail like the furniture and the ceilings and all that stuff because that's just too much when you're working in schematic mode. However, all of that stuff is still there. When you go into the catalog manager, you can see it all in relation to one another. And then when you output this to Revit, it's going to produce that same arrangement in native Revit objects. So the other interesting, unique feature about Schema in this regard is that we start with the data that was in your project. We might do a little bit of cleaning of wall joins and other things to make sure that the data is a standard of quality so that when we output the data again, we get rational results that don't need fixing. That's our whole goal, is to give you native Revit models where you don't have to go and fix it. Because if you spend that amount of time fixing it, then we didn't really create any value. So our whole goal is to give you a Revit model where it's ready to go. And so all of these things will then go into that Revit model. And whatever, if you made extensions to the properties, whether type or instance properties in those things in the model, you're going to see them when we put them back out into Revit because we're storing a binary blob of that definition. And then when we write it back out to a Revit file, it's going to have anything that you've put into that type definition or instance definition that we captured when we brought it into the assembly stored in Schema. So that's another big thing with us that makes us different than some other solutions. We're not taking our thing and mapping it to a list of families in Revit that just has generic properties. We're actually writing out the things that have your office standards already embedded in them. And that's one of the reasons you don't have to mess with the model and fix it afterwards, because we're preserving the data integrity of things that you've embedded in your previous Revit families. And, you know, that could be 10 or 15 years worth of archived data that you can leverage. And so this is the way that you get the knowledge out of what you've built in the past in Revit into Schema in a way that fast forwards you back into Revit in a way that's useful to you. Because if you have X other systems tied to that property data in Revit, when we write out a Revit model, it's still going to work with all those things that you've got as dependencies on there. So hopefully that all made sense. And so we've got several people on our team that were with the original Revit team, so we kind of understand first principles of Revit and why Revit breaks things when you try and do things, and what we do differently, which we will talk about, and how we generate the Revit models so those same things don't happen when you make a Revit model out of Schema. And to do this, I'm going to hand it over to Nikita, who's going to get into how Revit export works, how our analytic model works and drives the Revit export, because we're going to want to know all those things when we get into an API that uses that data.
Yeah.
Has everything I've been said clear so far? Do we have questions at this point? All right. So Nikita, what I think is I'll just tap through the slides unless you want us to show something else. And then when we get to the screen to you, unless you want to just switch screen to you now.
Yeah, let's better switch screen to me and I will go on.
Okay.
Yeah. 1 second.
Never mind the man behind the curtain.
Yeah, yeah. So let me share my screen. Do you see my screen, guys?
Yep.
You see the presentation, right?
Yep.
Yeah. Okay. So the logic of creating the export to Revit essentially driven by, as Marty said, the units that we initially uploaded into Schema, because all the demising walls that we generate between units, all the exterior walls, slabs, they all we take this information from the catalog. And I guess it was showing you, for instance, how this our catalog look like. And it typically the Revit container file with reusable units. And for instance, you know, like all these units has specific walls for demising walls, exterior walls, door families, and all this stuff. So when we upload the model back to Schema, we already know what type of demising walls we need to use between units, what type of walls we need to use as exterior walls, as roofs, etc., etc. So all these things generated on the fly, and I guess it will be better if I just show you how it works here. For instance, this is our simple schema building from the units that I uploaded from Revit. Here you can see only like a simplified representation. Let me rotate the canvas to make it better. So, like as you can see, there is just a proxy view of each unit. But when we go to the Revit model generation, we analyze all these units, how they stack together, and we remain only the necessary things. So you will never have a double walls or, let's say, you know, like exterior walls. They will be, you know, like a cleaned and polished data. So something like this. It means that just for use case. Let's say I want to move some units here, and like let's say it's my design solution, and we automatically define the gaps in our layouts. And let's say here I have my layout variant applied to top floors, and it means when I save this building and when I go to my BIM model, I will see the model regenerated correspondingly. So I can see that I now have a courtyard, my demising walls become exterior, and all this stuff. And my roofs, my slabs, they all recalculated. So data is updated, and nobody, redraw the walls or redraw the slabs or roofs and all this stuff.
And we should point out for those of you who haven't used Schema that this view he's showing you, the analytic model, most Schema users don't see. It exists, but it's not exposed. We're going to expose it to you in Rhino. So we're just showing it to you in Schema ahead of time so you can understand it.
Yeah, exactly. So let me move it back like this to make it clear. So yeah, this is what we have. Our analytical model has a few items that we are going today reproduce from the Grasshopper. So, and then under the hood, it's basically a JSON file. We generate a JSON file which goes to Revit Expert. And yeah, this is what I previously showed you about how this model, how we generate this model. We on the fly analyze every connection on every unit and try to create always, like keep this scheme of a building as a single source of truth. And since there is a request for bespoke customization, some like a solution like a facades, and because it's the most architectural part of the design, and we decided to do following things. We decided to provide you access to this JSON file through the Grasshopper, and since this JSON file is a single source of truth, the Revit models that we will be able to export from Schema and the customization that you will be created in the Grasshopper, they always will be matched because the singles, there is a one point of connection, everything. So, and this is what we're going to do today. For those of you who will be follow me step by step, we will need a few plugins to access the model. This is our Schema plugin. You can download it through the package manager, and also we need a Swiftlet. This is a plugin done by Torten Tomasetti, and this plugin allows to read JSON files in Grasshopper. Is anyone familiar with Swiftlet or not?
Familiar, but it's complicated stuff.
Okay.
So Nikita, I want to interrupt you for a second because I want to show a piece of eye candy because we're going to walk you through stuff that's very technical, right? But I want to sort of give you an end state result of why you would ever want to do this, if I can share for a second.
Yeah.
So we actually have a situation where we've been looking at a project, right? And it's submitted to the city with a certain exterior scheme. And so we've modeled up that analytic building, and now we are configuring this sort of interesting facade, and we're using what we're showing you today to integrate the schema building with the facade pattern in a way that unifies them and then allows you to make a fully formed Revit model of both all of the interior coming from schema and then that exterior facade coming from essentially a Grasshopper definition and Rhino pushed into Revit. So that's kind of the idea behind this, is that you can make chunks of the building in Schema that end up in Revit. You can make chunks of the building using a Grasshopper script where you can manipulate it in Schema with just sliders using Shape Diver and then push that through Rhino inside into Revit. But either way, you could be a computational designer where you're writing the Grasshopper script, or you could just be a designer where you're moving the sliders on something else that somebody's published as a preset without needing to know Grasshopper and Rhino, and still be able to do your design this way. And of course, there's obviously the universe of possibilities of taking something like this, combining it with AI rendering like Veris or whatever to have better geometric control over the outputs of something like that for your presentation material. There's a lot of directions this can go. And so, like I said, this is why we're interested in your feedback after you see what we're going to do today. All right, back to you, Nikita.
Yeah, thank you, Martin. So what we're going to do today is we're going to start from the beginning, and we will recreate all the connection to the Skema project. We will parse this JSON file, extract the main things needed to generate the facade, and I will show you also how to obtain windows, how it might be useful to you. So before we move forward, I've created for those of you guys, I created for you the accounts in Schema. 1 second, need to admit. Yeah. Hello. So I created accounts for all of you in Schema, and again, this is a dev branch. I will tap it into the chat. How you can access it. Yeah, this is a URL address for the test branch of Schema, and you all have accounts to the emails that you provided for the workshop, and with one master password. Let me put it to the chat as well. It's like this. So your email plus this simple password. After signing in, you should see the dashboard with one project under the AECTech tenant. Has anyone has success? Okay, cool.
Now, to avoid chaos, don't open that yet.
Yeah. So, yeah. Just let's just sign in, and we will proceed further. So, as you can see, you have I created this demo project for you guys to play with it today. In case you want to do some modification, you can simply duplicate this project, call it, like as you want, or just create a folder. Like let's say this will be Nikita's project. Nikita, yeah, like this. So you can create a folder, you can grab this whole project into folder, and this will be only your. So feel free to play with it, copy, adjust as needed. Okay, so let me open this project. I would like to start from obtaining the model. If we don't have any question about the schema itself, we can dive straight into the working with the Grasshopper. Okay, cool. So I will run, let me close the catalog file. Also, into the shared folder, you can find two Revit files for those of you who have Revit and who will work with Revit today. There is a facade file and building. I already exported this building into Revit so you can see how it works. And let me just quickly, I will show you for a sec the final output that I was able to get from Skema. So this is my final output. And as you can see, all the units, let me show closely right now. Yeah, all the units contains all the information that was previously embedded into the model group. And if we go to the floor plan view, we will have something like this. And as I previously explained you, like we don't have a double demising balls, everything more or less clear and ready to go. So this is a input project from Skema. And as you can see, one second. Sorry, guys.
Nikita, is this using what is pre-release Revit plugin at this point?
Yeah, it's from the, one second, guys. Let me stop sharing my screen for a second.
So one of the things about the pre-release Revit plugin while he's working on that you should understand is if you've used our stuff before, it was pretty much a one and done. You didn't have very much control over what came into Revit from Schema. We just sort of dumped everything in there. And the new version of the Revit plugin is different in that you can control which pieces and parts of the schema generated building go into Revit. So in this case, we've stripped out the exterior facade because we're going to do a custom one using Grasshopper.
Let me even just quickly show how, just an idea how it works. We have our plugin, which essentially the mirror of our web application running inside Revit. And when we open this project, we have access to, we literally can see what will be exported to Revit based on what we will do this export. And if we go to export, we can say, let's say we don't need to export exterior wall or exterior unit wall, or we don't need to export parapets. And this is what I did in this, this example. I just polish it and I say, I need only slabs, units, and this general core and shell of a building. This is how I obtain this model, because the idea is the rest we will create inside Grasshopper. So let me close the Schema plugin. Let me close this Revit model, because usually architects work like a different team working on the facade. And they usually work inside another RVT file and just link it with a main model in order to have all the flexibility here. And we will do similar approach. I have an empty facade, empty file, Revit file, which called facade, and you can find it on your Google Drive folder. It's just, you know, empty sheet, and we have empty file, and we can do when export everything here. 1 second. Yeah. So let's go to Rhino first. To Revit. Yeah, I will run. Let me guys prepare everything. Just wait for a sec. I need to rearrange my screens here. And yeah. So I have my Rhino file running from Rhino inside. And this is the placeholder files that I created for you. And there are some logic how to create a panelized facade. And basically, we will create the, firstly, we need to obtain this analytical model and get access to it. So the first things that we need to do here, and guys, don't hesitate to interrupt me if you have any questions. So the first thing that we need to do here is to access this Skema plugin. It's super, super simple. It has just two components. First one, essentially the authentication. When you click on it, you will have a right mouse click button and you will have a login button. And after that, you need to just provide your credentials, like here. And that's it. Now you are authenticated and you can get access to all companies because there is such approach that you as a user might belong to different teams. And we need to know the ID of a particular team to get access to this analytical model. So you basically will have just one team. And for this, we just can select the first item in our list. Yeah, it's okay. And yeah, and move with this. For you, it will be just a first item in a list. And for me, I guess it will be the last. Because I have this is my dev branch and I have a lot of, yeah, AECTech the last. I have a lot of tenant here. So yeah, this is my company ID. I also need to have the Boolean parameter here. Just a Boolean toggle to obtain this model where needed. And let's switch it to true. And also, to get this project, we need just two small pieces. I will explain it to you right now. In a schema URL, you can find two numbers, like one as a project ID and another as an option ID after they divided by slash. So it looks like this. I have a app schema site editor, and now I have just the two numbers. First one is a project ID, and second ID is the option ID. So I need to simply copy it into my components here. Yeah, and here. And now I just need to plug it into the project ID and option ID. And now you can see that everything is okay here. You shouldn't see any errors. And you can see that JSON is available. Is anyone follow me, or I can move on? Okay. So let me show you how it looks like. How can we work with a JSON file in Grasshopper? Essentially, it's pretty interesting thing because we can do a lot of workarounds and workflows built when we work with JSON and different web applications. First thing we need to do here is we need to parse this JSON, and in order to get the JSON token. And this JSON token essentially provides us a JSON object, which we need to read via read JSON object component in the Swiftlet. Yeah, firstly, in order to read it, we will see all the keys available in my JSON. And you see that there are a lot of components, but the first that we need here is massing. It's essentially like a general access to the Schema project. And in order to get this, I can go to oh, 1 second. GetJSON. Yeah, I need to use GetJSON K component. GetJSON object K. So here, I only need to provide the key that I want to access. And I need to access my sync. When I access the MySync, I have another type of object. I can also really quickly show you how it looks like just to see the overall picture. So this is my JSON file. It has MySyncs. It has a lot of object insights like units, all the units that I that used in my project, all the data about these units, the doors, type of families, type of walls, everything is stored here. So inside MySync, I have all my buildings because in Schema, I might have multiple buildings. So I need to access all of them. And I can do the same here. Firstly, I can read what type of keys, what type of keys I have in my, 1 second here, what type of keys I have inside MySync. And as you can see, the same that I just showed it to you. I have units, I have buildings, and this is how I can read all the keys and access. This is how I can know what I want to access. So let's do this. Let's access buildings. And yeah, now we have our buildings. And let's do the same here. Yeah. Inside buildings, we have a set of, as I said, there might be multiple buildings. So meaning that output of this component of J object will be array. And you can see it here. And we need to use, read JSON array component. Now we have access to everything inside our building. We have some levels, we have slabs, we have walls. And essentially slabs and walls, this is what we need to get here. And let's do the same. We have our buildings and we need to access our slabs. And the same, inside slabs, I have array, essentially list of all slabs in the project. And I can do the same with each slab. Yeah. As you can see, it has a tree of all the slabs. And each slab has its property. In order to construct the polygon of a slab, we need to access geometry property. And as an array, again, we need to do the same here. Oh, 1 second. Okay, sorry guys, I just missing something. We can already have array and we can access directly the geometry. We can access the geometry And now we can read all the properties of this building. Yeah. And inside the geometry, it stored all the geometrical properties of a slab. It has type of layers. It has whether it has some openings like holes, and so on and so on. But we need only the polygon for this case, just not to overcomplicate. And let's say I want to read the polygon. And let me firstly show you how it looks in JSON file. I have my building, I have my slabs, I have geometry, and inside geometry, I have my polygon. This polygon is essentially array of three-dimensional points, x, y, z. And from here, we can easily convert it into Rhino points. And I can do like here. Oh, this is array. Yeah, sorry. This is array. We need to access an array. And for each point, I can access this one, and I can retrieve all the x values and y. Everything that I need to reconstruct my points in Rhino. So each of these components returns JSON value, meaning that I need to read it as well. I read JSON value. Yeah, I need to use component read JSON value. In this component, this retrieves different types of values, because sometimes it might be Boolean, sometimes it might be strings, sometimes it might be numbers. So there are just three types of values. So we need numbers. As you can see, we have x position of each point of each slab here. So, and we can do the same here and here. Now, yeah, we're good to go to create, to construct a point. Yeah. And we just plug all the x, y, and z numbers. So as you can see, I can see here all points for my slabs. And I easily can create a polyline and plug it to the polyline. And I need to make the curve enclosed in order to, and I need to set the closed through Boolean flag to make it close. So as you can see, I have all my slabs here. And we here directly connected to this particular schema project. You obviously might have your own project here. And it means that if I do some changes here right now in Schema, it will automatically update the Grasshopper file. Any questions so far? Okay, good. Let's move on. So just to make it more visually clear, let's create some surface for these polygons. But before we create the surface, let's firstly try to understand what else we can do with our model, because from here we also can understand not just the geometry. Let's say from each slab we might see the isRoof property as well. This is a flag which helps us understand which slab is actually a roof. So we need to make it like this, just copy paste and type isRoof. And now we have JSON value. Okay, I actually can copy it here. I can, oh, not here. I can copy it here, plug it, and now I have all the values for all the steps, and I can see whether it's true or false. So for all the roofs, it will be true. And essentially, this is the map based on which I now can use this patch component and simply use it as a use Boolean value as a pattern. And now I can see, I can list all my polylines. And when I create a boundary surface, let's say for, okay, I need to flatten the list with all the polylines to make it visible. So as you can see, right now I have only slabs, which is actually curves. As a use case for kind of automation here, we might extract all the roofs and we might build some zonal panel on top of a roof, and then we can do the export it to Revit. So high fidelity Revit model will came from Schema, but we might allocate some, I don't know, some other stuff and do automation on top of this roof. Or even using Rhino Insight, we can do all the slopes for the roofs. We can calculate different types. So we always have correct geometry. And we can do the same for all other slabs, as you can see here. And obviously, we can do some, just to make it more visually clear, we can say this is our slabs, and this is our roofs. And we can use watch component to make some colors here, just to make it, let's say, I don't know, something like this. Use it here and use it here. So we were able to retrieve all the slabs from the project.
Right, I'm going to throw a wrench in the demo and make a change in schema.
Yeah. Let's do this. So for instance, let's say
just the same one you did before.
Yeah.
Just to prove it works.
Yeah. I even can do, like a bit different things. Just to show you again how Schema works. I can, let's say, add more floors, and I can apply different layouts here. Let's say I want to have my vertical circulation. Because this is how Schema works. We combine different units that you allocate within the Schema floor plan. We combine it to the layout. So you might have different parts of your layout which will be penetrated vertically, and you can dictate how these layouts can be penetrated. For instance, for course, I need to have it on 7 on all the floors. And let's say here, I might want to have my residential layout. And I want to create this as a variant 2. And from variant 2, I want to create another variant. Let's say variant 4. So it means that now I can get rid of all these design options just to show, how
now he's
it works.
getting fancy.
Yeah. just to make just to add a bit.
Four-story sky bridge at the top.
Yes. Something like this, just to prove that we. And here I need to get rid of all this part of the corridor. So now I have my another layout, and I can easily say that this residential layout variant 4 should go to 7, 6, and 5th floor of this tower. So now I have something like this. I can go to my massing. I can go to check how my BIM model looks in Schema preview. And as you can see, we forgot to create the circulation. On this level, it created the exterior walls here. But the rest looks pretty well. So, now I know what the issue is. We do not forget it. This is kind of the latest feature. So the object that I edited here, it was created only on this specific floor, meaning that I need to move it to my residential floor layout, and now it appears on all the variants. So let's consider it as a groups, like a logical groups of the floor plan layouts and their attachment to the particular floors. Let's save it. Go to floors, go to BIM, and now we have something fancy here. And if I go to Rhino, I can recompute it, and I will see updated result in Rhino. As you can see, this is my roofs, and this is other slabs. Yeah, and this was some sort of a demo. Let's get rid of this stuff because we don't need it. Let's be consistent for the demo. Let's move to Rhino.
Thank you, Nikita.
Yeah. Thank you, Martin. So we did, let's recompute it. We have our slabs, and now let's do the same for walls. And let's say this is our walls, and we can follow the same approach. Just plug it. Okay, this is array. I forgot. Because we obviously have a set of walls. As you can see here, this is just one array. And each wall is an object. And we have a lot of options for a wall. Some offsets, on which elevation it's located, etc., etc. I wouldn't dive into all these details. What we need here in order to reconstruct the wall, because walls represented a bit differently. They are 2D elements right now in Schema, and we need to access a geom property, as you can see here, this one. And we can get rid of this. We can go here, and we can plug it here, and now we can have all the, we can see all the geometry properties for each walls. And geometry property itself is an array. Let me show you. Yeah, so let's do it like this. Yeah, let's go to any wall. And as you can see, geom property is just a list which contain 2 points, 2 2D points, meaning that we can treat it correspondingly because this is an array and this is an array of arrays. Now we have a list of values. List of JSON values. And if we plug it to the numbers, we will see. So essentially, this is all our, this is a tree of all my points. And if I simply trim my tree in order to get rid of all the unnecessary sub-branches, I will see, oh, 1 second. 1 second, lights. Wait a sec. Yeah, basically what we need to create here is we just need to, it's already, it's a value. Yeah, got it. I messed up. Yeah, this is a tree of all my values. And in order to create this point, I just need to take the correspondent items from my list. So the first point will be the start, and the second will be the end. The same as we have in Rhino cures. Let's say this is my second item. And now I can create the point. Construct point. I can go here. And as you can see, the points became appear in 2D. In order to get Z position of every wall, we need to go to our another property of our walls is elevation. Let's show it again. Yeah. Let's firstly show you where it, not this one, which is an object. Here and read all my keys. So as you can see, our walls, they have a property elevation, which give us elevation of each wall, because this is how it's easier to reconstruct in Revit. We need to know start Z and elevation of this case. Yeah. Let's do this. And here we need to create elevation. And we also need to make our tree matched. So meaning that we need to duplicate our numbers, because we need to have yeah, I will use repeat component, because we need to have the same elevation for every point, and I need to set it 2 times. Now I can plug it to, okay, yeah, for sure, I need to craft it. I need to craft my tree 2 times. Why doesn't work? Yeah, sorry. Because this is a JSON value. Sorry, I forgot to add one more step. This is a JSON value, and we need to read it, and we need to read it as numbers, and now everything should work. So we have points of all our walls in Schema. And it means that we can create the polylines like this. But before creating the polylines, we need to get rid of all the sub-branches as well. Yeah. Now, as you can see, we have access to all the walls that we generated in Schema. And the logic will be the same. If I do any changes in Schema, it will update it automatically. And all these walls, they also have property. But before we move on, let's make it a bit more visually clear, just to show all type of walls. So first I want to create I want to create the surface of every wall. Endpoints. It's better to do it like this. And yeah, I need to create vector point component. So here I make a vector along the curve, and I need to use this vector in order to construct a plane. And in order to construct the plane, construct plane. Origin of my plane will be the beginning of the curve. X direction will be my vector along the curve, and Y direction will be my unitized Z vector. Now I have plans for every wall in my project. And it means that I can easily create a rectangle for every wall. Rectangle. Oh. I can create a rectangle. I can use this plane, and I need to construct the domain. I need to construct a domain for both for Y and X positions. And for Y position, we will take the curve length. Take the length of my curve. And this will be, this will be the kind of a length of my wall. And as you can see here, I already have all my walls. Now I need to create Y positions, and the same. We will use 0 as basement and 0 as basement here, and we need to parse our property user height for every wall. The same here. We can treat it user height. As you can see, we have a list of values, and we can read it really quickly. And all these walls, now we know the height of each wall. And when we plug it, we will see all our rectangles.
Can I ask why you would generate the rectangles instead of, say, extruding the curve in the Z direction and just make a surface?
Yes, it's also definitely possible. Yeah. Yeah, it's just one of the options.
Okay,
I just,
yeah.
I just Yeah, it definitely the more straightforward way to create this surface, but I just build entire pipeline creating the planes for every wall, and everything inside is built around the plane. So it's completely optional, right? So it's it's
Yeah, I
just
suppose the way you did it is maybe like computationally it's lighter than generating the surfaces.
It should be light, definitely lighter than generating the surface. I'm not sure. I cannot tell you 100%, but
Yeah.
it seems that more straightforward way to do this. Sorry, I cannot understand why I have incorrect height of my walls.
You just gotta graft your Y. The Y
Yeah.
input be a rectangle. There you go.
Yeah. I need to grab it. Yes, as well. Yeah, exactly. Yeah. Thank you. So I have all my walls, and I definitely can create some geometry for it. So, but all these walls, they also have their specific types. So, for instance, we can parse the same property here, and we can use search for function property. And this is essentially the same. This is a value. And as you can see, we can do it here. We can see the string value of all the type of walls. There are some specific type of walls, and I will explain it to you right now. What does it mean? And the best way is to create a set here to see all unique shapes. Right. And if I go to the set, okay. Yeah, if I parse all the strings, and it gives me all unique type of my walls. So in my project, I have external unit walls, this is an alpha version of our JSON. Our API naming is terrible to understand natively. We will rename it when it go to production, but essentially, when we go to let's open my catalog file, just to explain what is external unit wall, what is external general wall. So when we upload our catalog, we have a type of walls which marked as which has exterior property. And for this wall, we use the type of wall which came from catalog. So let's say if you have everywhere you have the same type of wall, we will generate this type of wall which is dictated by the catalog. But let's say in some cases, this demising wall might become exterior. In this way, it will be general external wall, not external unit wall. And we just did it in order to, in some cases, a user want to separate them. And let's say create one type of facade for the edge cases and white type of facade for the walls where the windows located. We might have the same, but it's up to us how to proceed with it. Let's move to the here. So, and I obviously can do following. I can go to my, just to preview these walls. Just to preview all these rectangles. Okay, but let's instead of rectangles create a planar surface. I need to replace my X and Y. So yeah, now I have all my surfaces. I can plug it with my geometry component and I can see all my walls. And in order to see it visually, all my types, I can create a different color representation of the colors. So like this, I have 4 types of walls, and I can create my color swatch for every type of wall. Let's say do some colors here. Like this. Say something like this. And if I plug it to, now I can create a map. So I have 4 items like my type of walls and 4 colors associated. And if I create a list, I can all my 1 second, all my map as an item and list as a list. And as an output, I will have all my walls colored correspondingly, like exact colors for each type of wall. And if I plug it here, I did.
You missed the graph again. You got to watch out for that.
Yeah. Yeah. I missed the graph. Yeah. I need to graph it here.
I think you might need to graft out of the list item, not the set creation. A little too soon. So
1 second.
remove it from the L. No graft on the L, but the output of the list item, which is the next to the I output, that one wants to be graphed.
Yeah.
Okay. List versus a tree always takes some time.
Yeah. Agreed. It's slow.
It still might need, it's the I output you want to graft.
But why?
The I output.
But
the
why?
list.
Sorry, I just missed. Yeah. The map, yeah. Just miss it. I guess we will next one we will move on. Yeah. Sorry guys. I just missed something. Yeah. And this is what we have. We have all our demising walls, we have our parapet walls, connected exterior walls, and connected regular walls. So here, this is the situation what I explained. This is a 1 unit aligned with a cell of a building, and this wall became another type. The same here. So I explained in all these details because there might be different cases how you might treat all these elements, knowing the structure. So when we have all our walls, in order to get my algorithm works, I also wanted to show you one more thing here. I prepared these placeholders, and I wouldn't waste time diving into all these details because it's probably not so important, but it's just a Grasshopper things. I also might want to have all my openings without openings within my walls, and they also an array. Some walls might have openings, some might not. And as you can, okay, it's just an array. I wouldn't see it here, but if I read this array, read JSON array. If I access it, I can see that I have some, I have some walls without openings, some with, as you can see. And I here need to filter them. Yeah. And this is why I use these predefined components you can find. I essentially search for a list with a length 0 and get rid of all the windows here. And here probably I need to provide my my actual walls, the lines where I need to allocate my windows. This is my polylines. It goes here. MCG token parameter. Okay, yeah, it should go to directly to openings because I need to read here openings. Again, this is the most straightforward approach. So, and what we have here, we have we don't have it. Just give me a second, guys. Yeah. Nothing standardized, doesn't work. Yeah, have all the position of all the walls. Yes. Yeah, perfect. Just wait a sec. Yeah, I need to flatten all my curves, which goes to Windows before. Yeah, and this is what I have here. I have all my walls, which goes from Revit. Basically, like this might be useful if you can, let's say, in Revit, I might know the approximate position of all my walls, of all my windows, right? But when I do the facade design, I might want to create it something differently. I might want to replace all my walls, or replace the families. And here, I can just receive the basic starting point of where the windows should be placed, what is the width, and so on and so on. And here, all my windows, they're located on one wall. And so they can easily translate it to Revit for run inside. Any questions, guys? Does it make sense to you?
Makes sense. I mean, I'm assuming floor openings are treated the same, maybe? Unless
Floor
the object-
openings?
Yeah.
Yeah, exactly. If we have some holes inside floors, they will be as a nested objects inside. Exactly, like, inside the floor. Yeah, for sure. Yeah. Why would we, maybe we can take a small break, 5 minutes or so, just to drink a bit water.
Great suggestion.
Yeah, thank you, guys.
See everybody in 5 minutes.
Yeah. From here, we have our building, we have our walls, and below these placeholders, I prepared some things how to. I wouldn't dive into all this creation. We will just create it. I will just explain what is happening here. So here we filter all our walls by function, and our goal is to have all interior wall, which might be demising or internal, and and here is just a value list where all these type of walls match. So I just filter in here, and I also get all my external walls and parapet walls. I will just, I need to have all my curves for walls, all my walls lines. And let's check all walls curves. Yeah, I will just rename it. So I will use this telepathy component in order to avoid all the spaghetti. Walls curves, I guess. If we rename, it will be run automatically. I need to have all walls curves. Yeah, now it works. And this is all walls as objects. I take it here, and all my walls as objects. Yeah, I can make it. Yeah. Some of them. Okay. Need walls as objects. But I did array. I did a list of all my walls. So essentially, what happened here? We take all our walls, we filter them. So now we have all our interior and demising walls, and on another hand, we have all our all our facade lines grouped by belonging to particular. So I kind of group all the walls which has the same X and Y position in order to have this vertical stack of all the walls. So my goal here is to have the surface of each wall. And this, guys, is it's definitely not like a perfect approach how to deal with all the works. It's just, and I'm not a computational designer. This is just an example of how we can work with the schema data and what can we build on top of it. So basically, what I did, I just provide all this filtering for walls. And finally, I will have all my facade lines and all my demising walls. And here we did pretty interesting thing. Let me firstly run our component. From here, we call Schema API, which can generate facade design. So it means that using Swiftlet from here, we can access any source which can generate like any algorithm. We just take one of our algorithms that we did in the past, and it's pretty interesting thing. Let me switch off all the walls. Windows frames, yes. Let's switch off all the windows. And I will show you what's happening here. I have a set of walls, exterior and demising, and I have an algorithm on the Schema backend which can allocate predefined size, predefined panels in a way in order to avoid abstraction for the walls. And this is how it works. If I switch off all the panels, I just want to show it to you first. Top wall, bottom wall, and show all the panels. Yeah. As you can see, it's wall by wall. It's split to the panels in a way where we will have inside each panel, we will have some glazing areas like here. And all this data, it comes from the simple mapping for all the walls. This is kind of an input for the algorithm. As you can see, it has a list of ranges, parametrical ranges for every panel. And for instance, we might have let me show you, it looks like this. We have a step 1, we have a step 2, step 3, step 4, and step 5. And for every this item in this range is essentially minimum and maximum length of every panel. So it's kind of a description how the particular size of the panels can be stretched. And for instance, from 2 to 4 feet, from 7 to 12, this one goes from 7 to 12. And here we have a mapping by panel glasses. Essentially tell us what panel is solid and what panels is glass. And it looks like this. We have a solid glass, solid, solid glass, solid glass, solid. We have kind of a pattern for every panel. And we have another panel which has only solid glass, solid step. Hope it makes sense.
So the goal of this solver is to make a alternating transparent, non-transparent, where the non-transparent portion is driven by the location of the demising wall intersecting exterior surface.
Yeah, exactly. Panels lines made. Let me show it. I guess it will be so here. Analyze made. I create all my glazings. Yeah, this is all my glazings. Not this one, and not this one. I need to. Let's see this. Let's do that like this. So this is what algorithm provide me, where let's say I have one panel, and this is my another panel, and this is all my just the places where the glass elements can be allocated. And based on this input, I did a lot of some sort of adjustments in order to, like for every wall, create a window. I double them like first floor and second floor in order to create kind of the panel which can go through pair of floors. And this is how this result finally looks like. Let me switch on all the geometry. Yeah, and let's get rid of all these elements, all the visibility that we did previously. So yeah, this is a kind of all of my panels, and I can see that they are not intersected between the demising walls. So I have my studio unit and I have a window, and I can be sure that windows are not intersected with the walls. And it's obviously the prefabricated panels. So the idea here is to show that using this approach, we can build absolutely different type of automations. We can reach out Schema API and have access to some optimizations, right? So if you are a Schema client and you need some specific logic, we can embed this logic not just into Schema, but we can provide you API to our services, and you can reach out it from Grasshopper. And yeah, and also obviously you can build any automation by yourself, knowing where the walls located, where the windows, and etc., etc. Hope it makes some sense to you guys. So I guess there is no sense to dive into the details how to generate this geometry. It's absolutely custom things that everyone can customize as they want. It's not a main topic here. I just wanted to show that how we can export it into Revit. So you can export it to different ways. And I personally tried, yeah. The first thing we can do here, obviously, to export into like direct shapes, like the most straightforward approach. And we will have all, as you can see, we have all our panels, panel with 2 elements, panels with 1 glazing elements, and so on. And they grouped by walls. Obviously, it can be anything here. And I also enable here my curtainwalls, my glazing elements, and my mullions, my glazing elements, and so on. And everything is here baked as a simple dummy geometry in Revit. I just assigned every material correspondingly, and now I have my facade in Revit. Yeah.
And you can take wall panels and assign them as wall categories so they cut correctly in the plan, or that sort of thing.
Yeah, absolutely, absolutely. I wouldn't cover it as a Rhino inside Grasshopper tutorial, but the point here is that we have all the data, like lines, windows, everything, and we can treat it as needed. I personally did some tests with experts in it, everything as a curtain wall, like a curtain wall embedded into another curtain wall, but doing it from Rhino inside is a complete mess and waste of time. Obviously, it makes no sense at all. So I just come up with this approach that direct shapes works pretty well. We can treat direct shapes as walls, as categories, and everything will be okay in Revit. But we obviously can create some walls instead of direct shapes as well. So just to showcase how output final looks like, I actually wouldn't import this project. I will just, yeah, from here I can just link my
Link the other
project that-
schema export, right?
Yes, exactly. That you can.
That we showed
you
at the
have-
beginning.
Yeah,
So then the nice thing is that the schematic analytic model is the registration space that keeps everything all together.
yeah. As the source of truth is the same, the result will be the same. Oh, okay. This, I guess it's not this building. I did a few tests previously. Okay.
Let's make sure you get the right number of floors.
Yeah. Yeah. One second, guys. Give me a few seconds. Yeah, I get rid of a few floors. Yeah, I get rid of a few floors when I did it previously. But what we can do here, let me share my screen. Let me share my screen and let's add a few more floors. And we can do the same. I need to switch my residential variant to, and I need to create here circulation layout. The same vertical circulation, residential variant 2. I can go here. I can go to my Rhino. And I can just
Recompute and watch
compute
Revit
it.
update.
Yeah. So, yeah.
Cool.
So
mean-
this is, yeah, go ahead.
I was just going to say the only thing I like the direct shape does have some downsides, right?
Yeah,
The joining being the major one. Like you won't get
yes, absolutely. But since I tried as a panelized facade, there is a joining is another issue. It is completely architectural issue. You know, like my idea was to start. Okay, we need to develop some use cases, practical use cases, and this one essentially the real building from one of our clients. And I just, you know, like as an architect, I was trying to replicate it. And yes, I agree. Definitely,
they probably look like that when they put it together, right? In reality.
Yeah. But yes,
You would have to
I
design the corner condition as part of the panelized solution anyway. So
yeah,
Exactly.
now we're in
Exactly.
different land.
Yeah.
yeah.
Cool.
So yeah, basically for the exterior walls, we have three options to export as a curtain walls, which is completely horrible. And we have direct shapes and generic walls. So for this use case, we just select generic walls. It's just a proof of the entire workflow where the schema is kind of a mediator of the source based on which we create the BIM model. So yeah.
There's actually a hack in the Revit API that might make this look like magic. That's probably not very well known, but we can talk about that and maybe get to it in the in-person workshop.
Yeah.
I love it. So, but then again, I'm biased. We hope you guys enjoyed it. Any questions about what you saw?
No questions here. I think it's really impressive, and yeah, look forward to seeing more next week.
Yeah. Thank you.
Well, yeah, thanks for taking the time. We appreciate it. Looking forward to seeing you in person.